Good day, everyone. You are welcome to my YouTube channel, Everything Medical. On today's class, I'll be treating the fate of propionyl-CoA under metabolism. Let's dive into the class proper. What is propionyl-CoA? What is propionyl-CoA? Propionyl-CoA is a 3-carbon acid. Yes, it is a 3-carbon acid. It is being generated from the beta oxidation of oil-chain fatty acid. There are some other metabolic pathways that tends to generate propionyl-CoA, such as the metabolism of valine and isoleucine. This propionyl-CoA is the only fatty acid that is gluconogenic because the propionyl-CoA is being metabolized to succinctly through the methyl-malonyl-CoA, either the L-methyl-malonyl-CoA and the D-methyl-malonyl-CoA. As you can see, it is the only fatty acid that is potentially gluconogenic because it is a secondary precursor of gluconeogenesis. They are primary and secondary precursor of gluconeogenesis, but this propionyl-CoA is a secondary precursor of what? Of gluconeogenesis. Now let's dive into the metabolic pathways proper on how its fate undergoes to generate succinctly, which enters the TCA cycle to generate oxaloacetate. Let's go proper. First of all, propionyl-CoA is carboxylated to D-methyl-malonyl-CoA. It is what? Carboxylated to D-methyl-malonyl-CoA. Automatically, that is a CO2 fixation reaction because CO2 is being added and it is a carboxylation reaction. So we have the D-methyl-malonyl-CoA. The D-methyl-malonyl-CoA by the presence of an enzyme known as the biotin. By the presence of the coenzyme known as the what? The biotin. Because the biotin is a bioactive form of vitamin B7. So the enzyme called pyruvate carboxylase that carboxylates propionyl-CoA to D-methyl-malonyl-CoA is a biotin dependent enzyme. So it is propionyl-CoA carboxylase. This propionyl-CoA carboxylase, and it uses biotin as its coenzyme. So let's write biotin here. Biotin. But then, one ATP is being utilized to feature the reaction because one ATP is being used so that this propionyl-CoA will be carboxylated to D-methyl-malonyl-CoA. So the coenzyme goes this way. You have the ATP will form the ADP plus P plus PI, not PPI, plus PI, which is inorganic phosphate. So then, this is how the step 1 goes. This propionyl-CoA is being what? Carboxylated to D-methyl-malonyl-CoA by the presence of an enzyme called propionyl-CoA carboxylase, which is a biotin dependent enzyme. Then step 2 goes like this. D-methyl-malonyl-CoA is being converted to L-methyl-malonyl-CoA. L-methyl-malonyl-CoA by the presence of an enzyme known as the racemase. The the racemase enzyme. The racemase enzyme is the enzyme that converts D-methylmalonyl-CoA to L-methylmalonyl-CoA. This is the step 2. Here is the step 1. Here is the step 2. Why step 3 goes this way. Step 3, L-methylmalonyl-CoA is being converted to what? Succinyl-CoA. To succinyl-CoA by the presence of an enzyme known as L-methylmalonyl-CoA mutase, or the mutase enzyme. Mutase enzyme. This mutase enzyme requires the vitamin B12 coenzyme known as adenosine B12. It requires what? Adenosine B12. Adenosine B12 is the coenzyme form of vitamin B12, which is the cyanocobalamin or the cobalamin. So this mutase enzyme tends to catalyze the conversion of L-methylmalonyl-CoA to succinyl-CoA. Then this succinyl-CoA enters where? It enters the TCA cycle to generate oxaloacetate. And oxaloacetate is the profound precursor of chronogenesis in TCA cycle. So it enters where? The TCA cycle. The TCA cycle. To generate what? Oxaloacetate. It enters the TCA cycle to generate oxaloacetate. And oxaloacetate is what is a profound precursor of gluconeogenesis in TCA cycle. Now, why is it that the propanyl-CoA is a precursor of gluconeogenesis and acetyl-CoA is not a precursor of gluconeogenesis? Here are the reasons. The main reason is that the propanyl-CoA is being metabolized to succinyl-CoA, and succinyl-CoA did not enter the step 3 and step 4 of TCA cycle, because had it enters those 2 steps, it would have been oxidatively decarboxylized as a 3 atom of CO2, because acetyl-CoA is being what? Oxidatively decarboxylized in step 3 and step 4 of TCA cycle as a 2 what? Atom of CO2. And that is the main reason why this propanyl-CoA is a precursor of gluconeogenesis, why acetyl-CoA is not a what? A precursor of gluconeogenesis. Then, what are the applied biochemistries of the FATE of propanyl-CoA? Here it goes. Number 1, applied biochemistry. Applied biochemistry. Number 1 is the propionic acidemia. Propionic acidemia. What is this propionic acidemia? It is the deficiency of propanyl-CoA carboxylase, because once this enzyme is deficient, there will be an elevated level of propanyl-CoA in the blood. So it is called propionic acidemia. Then number 2 applied biochemistry that is here is what? L-methylmalonyl-CoA aciduria. It is what? L-methylmalonyl-CoA aciduria. L-methylmalonyl-CoA aciduria. It is the deficiency of what? Mutase enzyme. Because once mutase enzyme is deficient, there will be an elevated level of L-methylmalonyl-CoA in the what? In the blood. I mean, in the urine. That is how it works. So these are the fate of propanyl-CoA, which is being generated from the beta oxidation of what? Odd chain fatty acid. Because that I said earlier that it can be also be generated from the metabolism of valine and isoleucine. This is the end of the class. Thank you for watching.